I am Dr.P.S.V.Shanmukhi, Associate Professor, Department of Physics, Aditya University. Now, I am going to explain about the particle in one-dimensional potential well or the potential box. At the end of this lecture, student will able to derive the eigenvalues or energy values of an electron in the one-dimensional potential well, and he can also derive the eigenfunctions or wave functions of an electron in the one-dimensional potential well or potential box. Here, say this is say one-dimensional potential well. It is having infinite depth. Let us consider an electron is moving completely freely in the one-dimensional potential well of infinite depth and width small capital L. Width capital L is taken. That means at one boundary x is equal to 0, another boundary x is equal to L. The depth of the well is infinity, that's why the height of the walls, it is given by infinity. So here the electron is moving completely freely. Since the electron is moving completely freely, it contains only the kinetic energy. Its potential energy V of x is equal to 0. Potential energy is 0. Anyhow, here I am going to solve this problem. Solution is nothing but what is the behavior of the electron. Behavior means what is the energy, what is the position. That what we are going to derive. Anyhow, to solve any problem related to the atomic world, we can use the Schrödinger wave equation. Since this is the one-dimensional problem, let us take the Schrödinger wave equation. Say the time independent Schrödinger wave equation, d square psi by dx square plus 2m by this is h cross square e minus v into psi is equal to 0. D square psi by dx square plus 2m by h cross square e minus v into psi is equal to 0. Anyhow, in this potential well, v of x is equal to 0. Means it is moving completely freely. That's why it has only kinetic energy, no potential energy at all. That's why v is taken as 0. Substitute v0 in this equation number 1. What do you get? D square psi by dx square plus 2m by h cross 2me by h cross square e into psi is equal to 0. This one equation number 2 we get. Now this is the equation for this present problem. Okay, to solve this one, let us assume the solution as psi of x is equal to a into something plus b into something, where a comma b are the arbitrary constants. A sin kx plus b cos kx is taken. So the solution of the equation number 2, it is of the form psi of x is equal to a sin kx plus b cos kx. A and b are the arbitrary constants. We can get them by applying the boundary conditions. What are the boundary conditions in this one? Actually, the boundaries are x is equal to 0, the first boundary, x is equal to L, the second boundary. But the boundary condition at x is equal to 0, what is the wave function? Means on the wall, what is the wave function? And at x is equal to L, what is the wave function? Actually, we cannot find the electron on the wall. The electron is completely moving freely in the infinite potential well. We are just saying infinite potential well. To come out of this one, we have to supply infinite energy, or to move the electron here, V of x is equal to infinity. So for my convenience, I just divide this into region 1, region 2 and region 3. In the regions 2 and 3 only V of x is equal to infinity. In the region 1, V of x is equal to 0. So in the region 1, okay, can we find the electron at x is equal to 0 means on the wall? Not at all. So at x is equal to on this wall also we cannot find the electron. That is nothing but the ground. That's why let us apply the boundary conditions. The boundary conditions are at x is equal to 0. No electron is found, no wave function psi. Psi of x is equal to 0 at x is equal to 0. At x is equal to L, psi of x is equal to 0. These are the two boundary conditions. Now first apply the first boundary condition. Psi of x is equal to 0 at x is equal to 0. In this equation number, say that is 3. Therefore, what do you get here? 0 is equal to A sin kx, x is equal to 0, A sin k0 plus B cos k0. Sin 0, 0 already we know, cos 0, it is 1. That's why we get B is equal to 0. Actually, our assumed solution, psi of x is equal to A sin kx plus B cos kx, A into something plus B into something. But substitute applying the first boundary condition, we are getting B is equal to 0. That's why how the equation will be modified? The equation will be modified as psi of x is equal to A sin kx. Again, we don't know what is A. We will determine that one later. Now, coming to psi of, apply the second boundary condition. This one you apply here. Psi of x is equal to 0 at x is equal to L. Means psi of x 0, A sin kx, x means L I am taking. A sin kl is equal to 0. Means A into B is equal to 0 means either A may be 0 or B may be 0 or both may be 0. Here, either A is equal to 0 or sin kl is equal to 0. A should not be 0. Why? Because already in our assumed solution, B is 0. That's why you should not take A 0. A should be non-zero value. That's why sin kl is equal to 0 we get. Sin kl is equal to 0 means, what do you get here? Kl is equal to n pi. Sin 0, 0. Sin 180, 0, sin minus 180, minus pi 0, sin 2 pi, 3 pi, etc. All are zeros. That's why KL is equal to plus or minus n pi, or simply take it as n pi. K is equal to n pi by L we get. Now, substitute this K is equal to n pi by L in our equation or solution. Already this term is 0. You will get A sin K x, that means n pi by L into x we get. Now this is our solution, but we don't know what is A. That what we determine later, and we have to get the energy expressions also. For that one, you observe here, actually say in the previous one, first equation you observe, this is d square psi by dx square plus something into psi is equal to 0. So in that form, I just write here d psi by dx I take. Differentiate equation number 7. You will get A into sin theta means into differentiation of sin theta cos theta we get. A into n pi by L into cos n pi by L x we get. Again I take d square psi by dx square, and on simplification we get the equation like this. D square psi by dx square n square pi square by L square into psi is equal to 0. You equate this one to equation number 2. So what do you get here? Equation number 2, that is 2m by h cross square is equal to n square pi square by L square. 2m by h cross square is equal to n square pi square by L square. So from that one, you just get, say, 2m by h cross square. E is also there. E into 2m e by h cross square is equal to n square pi square by L square. From that one, you will get E is equal to n square pi square h cross square by 2m L square. So you give different values to n, you will get different energy values. That's why I am just writing this as E suffix n. N square pi square h cross square, that is h cross or h cut square by 2m L square. Actually this h cut is h by 2 pi, already we know. That's why on simplifying this one, we get this as n square h square by 8m L square. So what is the final energy expression? En is equal to n square h square by 8m L square. You give n is equal to 1, you will get E1. So n is equal to 2, E2. So the energy values are E1, E2, E3 and so on we get. These are the discrete energy values called eigenvalues or the energy values. Say this is x is equal to 0, x is equal to L. Different energy values let us take. So n is equal to 1, 2, 3 and so on. We get E1, E2, E3 and so on. So E2 is equal to 9E4E1, E3 is equal to 9E1 and so on we get. Anyhow, energy is discrete and quantized. So E1, E2, E3 are called the discrete energy values. They are called eigenvalues. Now, I want to determine this capital A. For that one, let us use the normalization condition. That normalization condition, psi of integral 0 to L mod psi square dx is equal to 1. In case of one-dimensional system, so this is the normalization condition. What is psi actually? A sin n pi by L into n pi by L x. That what we know. Substitute that one in this equation. We get a square sin square n pi by L into x dx we get. Simply a is a constant term. Write outside the integration. That a you write outside the integration. Integral 0 to L. So this is actually integral sin square theta means 1 minus cos 2 theta whole divided by 2 we get. So on this context we get 1 by 2 into 1 minus cos 2n pi by L into x we get. So again integral dx means x we get. X term is there, and integral cos theta, that is actually sin theta we get. Therefore, so this term we are getting sin 2n pi by L x divided by 2n pi by L we get, or the limits are 0 to L. On simplifying this one, actually sin 0 0 and L and L will be cancelled in case of sin 2n pi. N you give n is equal to 0, 1, 2, 3, so on. That's why you'll get 0 for the second term. So only the first term remains. Automatically on simplifying this one, you will get a is equal to root over 2 by L we get. This is capital A. Substitute in the previous equation means psi of x is equal to a sin n pi by L into x we got. That a is written here. You will get this as sin of x is equal to root over 2 by L sin 2n by L into 2n pi by L into x. Anyhow, give different values for n, you will get different wave functions. That means you will get the wave functions psi 1 of x, psi 2 of x, and psi 3 of x, and so on we get. These are the discrete wave functions. These wave functions are called eigenfunctions. What are the eigenvalues we got? E1, E2, E3, so on. N square H square by 8 M L square. These are the discrete energy values, eigenvalues, and psi 1, psi 2, psi 3, and so on. They are called discrete wave functions. They are called eigenfunctions. You just observe, give n is equal to 1, 2, 3, so on. You will get psi 1, psi 2, psi 3, half wave, one complete wave, 1.5 wave, 1, 2 waves, 2.5 waves, like that we get. These are the discrete waves. And you take the mod psi square on the y-axis, and x values are taken on the x-axis. Automatically we get the second graph. That mod psi square is the probability density. So for the first energy level, psi 1, okay, half wave we are getting, mod psi square, again we get like this. In the second energy level, if the electron goes to the second energy level, its energy is E2. 2 means one complete wave is there. For the second half, psi is a negative function, okay, but mod psi square is a positive, 2 peaks we get. Similarly, in the third energy level, 3 peaks we get. As per this graph, we can understand the maximum probable position of the electron. Means in the first energy level, most of the times electron lies at the center of the potential well. It never lies at the edges. Whereas in the second energy level, if the electron lies most of the cases at the center of the first half or at the center of the second half. It never lies at the center as well as at the edges. So in that way, by this graph, we can understand the maximum probable position of the electron. So coming to the summary of this one, here we have derived the eigenvalues and eigenfunctions of electron. What are the eigenvalues? Means what are the discrete energy values of an electron in one-dimensional potential well. Suppose this is a potential well, electron can go to the second, third, fourth, etc. energy levels, but it cannot come out of the potential well unless infinite energy is supplied. That's why you can treat this as infinite depth potential well or closed potential box also. That's why it is called the behavior of the electron in the one-dimensional potential well or one-dimensional potential box. So after the eigenvalues, we have determined the eigenfunctions or wave functions also. What are the discrete wave functions? From that one, what is the maximum probable position we have determined. Thank you.